Hello, today we are going to do derivatives, and I'm going to cover the four areas of derivatives. That is the normal polynomial functions, as you can see, part A, and we're going also to deal with chain rule, product rule, then the quotient rule. So I'm going to tackle questions in the four areas separately. This will make you understand it in an easy way. Now let's start with the first part, derivative of polynomials. So derivative of polynomials are mostly in this form. So when we have these derivatives, then we know that if you have been given f is equals to y is equals to, or f of x is equals to x raised to n, then derivative is expressed as dy over dx, then is equals to, you multiply down by n, then x, then you subtract 1. So that is a derivative, how we get the derivative of a function. So in this case then, dy over dx is equals to, then you subtract 1 from the power, multiply by 2, subtract 1 from the power, and then in this case, multiply, this is 1, multiply, then you get 2, subtract 1, you get 0. So you know that x raised to 0 is 1. Then for any constant, the value is equals to 0. So which means that your final solution in this question is 2x plus 2, because any number raised to 0 is equal to 1. That is the solution for the first part there. So when you're given a polynomial of this nature, the first thing that you should do is to bring the x's up by just doing the division there. So you can rewrite this one as 1 plus 2 raised to x raised to negative 1 plus 2 x raised to negative 2. So if you rewrite it that way, then you can see that it is very easy for you to get the derivative of each particular part. So we said that the derivative of a constant here is equals to 0. So 1 is equals to 0 here. So we go to the second one, which means that we are going to have negative 2, because we are going to multiply by negative 1. Then x raised to negative 2. Then down here, you're going to multiply by negative 2 times 2 here. You get negative 4. Negative 4, then x raised to negative 2 minus 1, which is negative 3. So, which can be written, you can rewrite this one as negative 2 over x squared using the laws of indices, then minus 4 over x cubed. So your answer can be written simply in that particular form. So in this part, that is part C, the easiest way for the students to do this kind of questions is rewriting them. So we can rewrite the following function as 2 raised to x raised to a half, because it is a root, then plus natural log of x. So then it makes it easier for you to work it out. So if you find the derivative of 2x raised to a half, then you find that you multiply down by a half, that is 2 times a half, then x raised to we have a half, then minus 1, okay, plus the natural log. When you're finding the derivative of the natural log, you get 1 over x. Okay, any natural log, you get 1 over x. So what do you get here? So when you simplify this, then you get that 2 goes by 2 here, so then you remain with 1 there. So then that is it will x raised to negative a half, then plus 1 over x, which can also be written as finally as 1 over root x, because a half is root, Because it is negative, you can take it to the denominator to be positive, then plus 1 over x. Okay, and that is your solution. Okay, we have also other situations like question D here. For you to get the derivative, as I've mentioned before, we're supposed to find, you to rewrite the equation, whereby we can say that it is y is equals to, it can be 1 over x squared over x squared plus x squared over x squared. Okay, and then you can simplify each of the part. So this one can be rewritten as x raised to negative 2 plus, when you divide this is raised to 1, so it will remain x raised to negative 1, and then the final one will be 1. So you see, by rewriting, then it makes it easier for you to differentiate. These are just normal polynomials, but written differently. So the student must have the skill to first of all know how to rewrite these particular functions. So differentiating now this function becomes easy for us. So dy over dx here is equals, now the first one we multiply by negative 2, then we subtract 1 from the power. Then you get the second one multiplied by negative 1, then you subtract 1 from the power, and then the constant becomes 0. So what do you get here? So what you get here is negative 2x raised to 3 minus x raised to negative 1. So finally, because this is negative 3 here, we can rewrite them as negative 2 over x cubed, then minus x so we can take it as 1 over x. So that one can be rewritten as 1 over x. Okay, so then 1 over x. So, and that is your solution. So these 4 questions, I believe they have given you some knowledge on how to handle different polynomial derivatives of polynomial functions of using different ways of rewriting. See, rewriting the functions. I think that is the best thing that we have learned in this particular area. Now, let's move to the second one. The second one we talked about is the chain rule. You can see the chain rule here. Okay, the chain rule here is a very interesting method of working out derivatives. So you find that if you've been given a function of this nature, it will be very tedious for a student to expand x squared plus 5, then you differentiate. So we have to use a different method that now we call the chain rule. Now, using the chain rule, given the function of that nature, then when we are differentiating, when you are getting f of x, then we'll have to get the dy over du, then du over dx, which is very simple. So in the first case here, a student has to identify what is the u. So I'm taking my u to be x squared plus 5. You see, x squared plus 5. So the first thing that a student has to look at now, we are now getting dy, the first part here is dy over du. Okay, so we have the constant which is outside, so we come and say what is dy over du, which now we have the constant, just leave the constant outside there. So our u, you see, when we are talking about u is equals to, we are talking about u is equals to this, but it is now raised to 3. Okay, so you see we have identified our u. So dy over du here, in this case, is equals to 6 u, because we are differentiating this, u raised to 2. So you have differentiated dy over du. So it is just like the whole function. Now, but then we identified the second part is we have du over dx. So what is our what is our u? U is here, and we have this. So which means we have to differentiate this particular function here. So du over dx, then it will be 2x, okay, because u is equals to x squared plus 5. So du over dx is equals to 2x. So what do we do then with the chain rule? The chain rule, after getting the 2, you multiply the 2. Multiply the 2. So we had dy over du, which is here. So it is 6 u raised to 2. Then multiply by du over dx, which is 2x. So we can multiply these ones first and then get 12x. What is our u? So we can go back and substitute our u. Our u is x squared plus 5, then raised to 2. And that is it. That is how we use the chain rule. Very simple and straightforward when we have power. So in chain rule, when you get a function that is raised to a power, just know straight away that chain rule is the one that you're going to use there. In simple terms, a student can just look at the function and do the following. So looking at the function, and the students can do it in a shorter way. In other words, is that if the student can get the derivative of this function and the derivative of the whole function, you know, what we have done is just getting the derivative of the inner function, the derivative of the whole function. Then you multiply the 2. That is all. So the derivative of the inner function here, as you can see, it is 2x, the one inside here, 2x. The derivative of the whole function, it is 6 of this, which is 6 of x squared plus 5. Then when we have this, then we are raising it to power 3, so it will be power 2, 3 minus 1, which is 2. So the student can still, anybody can still use that power as a shortcut for you to use the chain rule. So when you multiply, you still get the same solution, which is 12x, and then we have x squared plus 5, then raised to 2. So which gives you the same solution. But you look at it differently from the experience that you are going to get. My second example here involves E. Now, when you look at this part here, this is a composite function in most cases. This is a composite function, and it is raised to a power. Now, how do we differentiate this? Now, the first step is just like what we have already said. So the first part here, we are going to differentiate by parts because of addition. Now, the first part here, 2 is a constant, so from the experience we have gained above, if you say that u is equals to, for instance, x squared plus 1, then we say that in this case, we can now differentiate using the above method. But using the experience that we have gained here, so du over dx of this is equals to 2x. So we have 2x. So it is the 2x that you have that you can just multiply down here. Okay, then raised to, when you have this, then we say that dy over du, which now becomes eu. Okay, so what is the derivative of du? Sorry, here, what we are supposed to, before you just write the final part here, we can just say our y, just let me put it clearly here so that you say that our y is equals to this, so dy over du, you see, dy which remains e over u. So if it remains e over u, then you multiply here then by, so when you say dy over du times du over dx, so then we say dy over du, which is here. So you just say e raised to u multiplied by du over dx, which is 2x. But remember we had a constant here, which is 2. And then when you differentiate e is a constant, so you get 0. Okay, so what is your final solution? So we can really simplify this by multiplying here. So you get 4x e raised to u. And remember, our u is x squared plus 1, x squared plus 1, then plus 0. So this is your final derivative of this particular function. Okay, let's look at another example of chain rule. Now that we have our experience up there, it can be easier for us to get the derivative of this one. Now, this one is a composite function already here. Now, when you have this, we said, if this is your u, now let us now use the shortcut method. If this is your u, okay, let's do it that way. Du, this is your u. So we get dy over du. Du over du is the whole of this, okay, the whole of this, which gives you what? Natural log of this, it gives you 1 over x squared plus 1. And then just get du over dx. Now du is only what is contained inside the bracket, which is what? Which is, if you look at it, which is just 2x. So that first part, you find that you are getting, so when you multiply the two, then you get 2x over x squared plus 1. So you can see how it is easy for you to use the chain rule. Then the second part here, we have 2 cos this, so 2 is a constant, that's fine. Then we say this is our u, okay? So then we have dy, so if u is equals to pi over 2x, then du over dx is equals to, what do you get this one? Is equals to pi over 2, because it's a constant. Then look at y, so our y is equals to cos u. Our 2 is a constant, remember? Our 2 is a constant there, is equals to cos u. So dy over du is equals to negative sine of u. So then you just bring it around. So we say plus, when you multiply the 2, we have the constant which is pi over 2, then you multiply by negative sine u. So, and sine u, you know what it means, pi over 2x. So then you can bring it here and say 2x over x squared plus 1. Then you say plus, now this one will be a minus here, so we just go straight and just have our minus because of this, just have minus here, so minus pi over 2, which is a constant, sine u, and sine u we said it is pi over 2x. And that is your solution. Okay, you can see how you can use chain rule. So at first instance, you might find it difficult to do a chain rule, but then the focus should be when you look at a function and you see that it is raised to a power, just know that you're going to use the chain rule. Okay, my first part here, now we go to the part C, which is the product rule, another very interesting mathematical method. Now in the product rule, this is where we have two functions multiplying one another. And in most cases, you find that multiplying the functions and getting into one polynomial functions becomes hectic. So what do we use when we have two functions multiplying one another? So we have the formula for the product rule. So product rule is that we just say let u is equals to x plus 3. So you divide the two, you identify the two as u and v, and that. So for you to use the product rule, then you use the formula. When you have the product rule, use the formula u, then find the derivative of the first, that is uv, the second function. Then you add v, then the derivative of the second of the first function, just like that. Sorry, let me just put 12. So it is well, the derivative, you use the u, the first function, derivative of the second function, and then you use the derivative of the first function times the second function. So what do we have? This is very simple. So we have u, which is, we identify this one as u and this one as v. So u is x plus 3 here. Derivative of the second function is e raised to x. It does not change because it is 1x. Then plus the derivative of the first function, which is 1, times the second function, which is x raised to e raised to x. Now in that case, then we are done. That is all. Very simple. Then what we have e raised to x, 1 plus 3, 1, and that is x plus 3 here. Then we have plus e raised to x. So somebody can just simplify this. You can factor e raised to x, and then you get, if you factor that, what do we get? We get x plus 3, then we have plus 1, okay, which can be simplified to e raised to x, then into bracket we have x plus 4, okay, and that's the solution. That's the solution for that particular function. Okay, now let's go to example 2. So this, we were to name this one as A. So let's just remove these. So that's the product rule A, and then we move to B. Now, the same way product. Now identify your u, identify your v. So my u is equals to sine of 3x, and my v is equals to natural log of x. Okay, so as the formula, you saw it from here, okay, which is very simple here. So you use, for you to get the first derivative here, you just say u v dash, and then we have, then you find the derivative of the first one times the function of the second function. So what is our u? So sine of 3x. So from experience, then you just say that, you see this is a composite function, so you have to look at it keenly. So the sine of 3x, then the derivative of v, which is times 1 over x, and then we have u. Now the derivative of this, we said that this is our u and the whole of it. So we have, when we talk about u here, the derivative is 3, and then the sine of u is, we get it is the cosine of u, which means is the cosine of 3x. okay, like that. So, which now means that you have 1 over x here, sine of 3x plus 3, then the cos of 3x. Okay, and that is your solution. And that is your solution. So that is how to manage this. You can see you can do it so fast and so easy. Okay. So quotient rule, we can really do it also in a very easy way. For instance, when we have x plus 1 over x plus 2, you see, these are partial fractions. These are fractions, functions in form of fractions, which we can easily say that if y is equals to this, then we can easily say that we are talking the functions of the form f of x over g of x. So when you have this form of function, then we know that we are now supposed to use the quotient rule. It's division. We are now in the division area. Okay, so what did we say is the formula for this? So we also identify u as f of x and identify v as g of x. Okay, just like that. So then the formula now becomes so easy, v, so which is the second function, multiplied by the derivative of the first function, then you subtract derivative of the first, that is this, so we have second, here, sometimes make sure that you write the formula well. Then you multiplied by e dash, just like that, over v squared. Okay, let's look at it. Let's look at it keenly. So what is v? So look at v, which is our g, so which is x plus 2. Okay, then the derivative of the first, which is 1. Then minus the second one, which is u, which is x plus 1. Okay, multiplied by the derivative of the second one, which is 1, over the derivative, over v squared, so x plus 2 squared. So you get this one of in the form of x plus, that is x plus 2, and then the second one is x plus 1, because 1 has no value there, so 1, so we have x plus 2 minus x, then 2 minus 1, then it will be 2 minus 1, so which means you get the numerator you get 1, and the denominator, so the numerator there is 1, the denominator is x plus 2 squared, and this is your solution. This is your solution. Okay, that is how to deal with quotient rule. A second example here, we can just say natural log of x. If y is equals to natural log of x over x cubed, remember your formula, and you can easily, this formula here is very key. So you get so you write it v u derivative minus u v derivative over, then you get v squared, just like that. So which means you will have identified your u as natural log of x and your v as x cubed. Okay, then you just apply your formula. So what is your v? So your v is x cubed, then multiplied by the derivative of the natural log of x, which we said it is 1 over x. And then subtract u, so you go to u, which is natural log of x, then multiplied by the derivative of u, which is 3x squared. Okay, so you can realize this. This one will simplify to x squared. Then this one, you can write it as 3x squared, natural log of x, which can further be simplified to, you can factor out x squared, then you get minus 3 natural log of x. So you can see from the 4 areas that we have dealt with, you can easily go through derivatives. So easily, all the derivatives from like what we have done from the polynomials to the quotient rule in a very easy way and within a very short time. Thank you very much for today, and we shall proceed on with the next podcast. Welcome again. Thank you.